Today we are going to take uh, one concept of optical fiber. What are optical fibers and what is the working of optical fibers? Here, this is the applications of TIR taking place. We just see here an optical fiber is a device. An optical fiber is a device based on based on total internal reflection of light, TIR. Total internal reflection of light. Actually, what happens in it, by this, by TIR, a light signal, a light signal is transmitted transmitted from one place to another with a negligible loss of energy. Negligible loss of energy. So this is the meaning where we have come to know about the optical fiber, which is such a device which is based on the TIR, total internal reflection of light taking place inside it during sending the signals from one place to other place. Now let us see how this works, for which we will draw a diagram. You can see here about the how the ray travels as a signal. This varies the optical fiber. The two ends are, one end is taken as A, other end is taken as B, through which the signal comes out, and there is coating also, and this coating has its own this very coating can be shown by dotted lines, where we will show here the value of the refractive index. First of all, this very coating has refractive index equal to 1 by 1.5, and inside the optical fiber, the refractive index is 1.7. Now, how the ray or the signal enters at the point A, we just draw a normal and incident signal enters the optical fiber through the A end and it gets refracted because density is more, so the signal bends inwardly toward the normal, and at each point where the ray comes inside, once again the signal gets reflected back, and due to the high refractive index inside it once again bounces back internally and goes to the other end. The direction of the propagation of the signal is shown here with the arrow sign. Normal at every point of incident is shown here. It will just gets reflected internally inside the optical tube and then reaches to the other end from where it comes out and away from the optical fiber. It is seen here. It is a very long and thin pipe of quartz where the refractive index of the quartz is 1.7 of thickness nearly equal to 10 to the power minus 4 meter. This is the scientific value given, coated all around with a material of refractive index refractive index 1.5 mu value. A large number of such fibers are held together. A large number of such fibers held together held together to form a light pipe, and are used for communication of light. Communication Application of light signals. In the optical fiber, when the ray of light is incident, when a ray of light is incident on one end, one end at a small angle, then what happens there? Small angle of incidence, it suffers refraction from entering from air medium to the optical fiber medium of refractive index 1.7 to the quartz, and strikes the quartz coating surface, coating surface at an angle, at an angle greater than critical angle, and so suffers TIR and strike the opposite face again, and strikes the opposite face again. In this way, we see that at an angle, again at an angle I, which is greater than IC, and so again TIR take place, and again TIR take place. Ultimately, we see that the rays within the fibers suffers total internal reflection, and ultimately the ray emerge out, emerge out from the optical fiber, from the end B. In this way, the signal is transferred from one place to other place. The ray within the optical fiber suffers ultimately total internal reflections and comes out through the end B. So we see here that how the signals enters through the A end of the optical fibers and goes to the other end, and after taking total internal reflections ultimately comes out through the B ends. In this way we see that the signal transfer from one place to other place by using the optical fibers. So this is there is no loss of energy also. By using this there is no loss of energy also. So, we conserve the energy and transfer the signals from one place to other place.